Hello learners, and welcome to today's lesson of numeric patterns, where we are going to be focusing on those practice and application questions. Let's get down to our questions. So our first question there is saying, considering the following numeric pattern, that's 1, 3, 9, and 27, represent the numeric pattern in a table. So remember, for us to represent this numeric pattern in a table, we must know what the rule is, or at least we must know how to move from the first term to the second term, from the second term to the third term. Now, looking at our table, it is asking us of the first 6 terms. So we know that this is the first term, the 3 is the second term, the 9 is the third term, and the 27 is the fourth term. So we already have those first 4 terms, that is 1, 3, 9, and 27. Now, how can we get term number 5 and term number 6? Well, we need to see how we moved from the first term to the second term. Now, as you can see, from the first term to the second term, we have multiplied by 3. And since we are multiplying, this means that this is a ratio. Now, let's see if it is a constant ratio, because from term 2 to term 3, we are also multiplying by 3, which means that our constant ratio here is that 3. So from 9 to 27, we multiplied by 3. Now we need to know that from 27, how do we get to the 5th term? Of course, we are going to use that constant ratio, and that will give us an answer of 81. So our 5th term there is 81. And once we have that 5th term, again, we are going to multiply by 3 again, and that is going to give us an answer of 243. So that is us having filled out this numeric pattern in a table. Let's move on to our next question. Now, our next question here says, determine the rule or equation for this numeric pattern. Now, we have been given a 9, a 7, and a 5. So our first term is 9, our second term is 7, and our third term is a 5. Now, how are we moving from the first term to the second term? Well, we are subtracting by 2. So this means that this is a constant difference, because as we can see, even from term 2 to term 3, we are subtracting a 2. So what is this rule going to be? Well, let's use our table to help us find this rule, or let's fill out partly some of the table, and then we will continue and find that rule. So we know that the constant difference is a negative 2. So this means that we can fill out the first few consecutive terms. So the first term there is a 9, the second term is a 7, the third term is a 5. Now, if we were to continue with this pattern or using our constant difference, then we know that the next term there, or the fourth term, is going to be a 3, because we are simply subtracting 2. The next term is going to be a 1. The 6th term is going to be a negative 1, and the 7th term is going to be a negative 3. And this is obtained by just subtracting the 2. Now, what are we going to put in the place of n? That is where our rule goes, and our rule is going to help us to find the 20th term. So let us find that rule. Now, we know that the rule is a relationship between the term number with the constant difference. So we know that we are going to take our term number, multiply with the constant difference, and that is with our negative 2. Then we are going to add or subtract a constant value. And we need to find that constant value. So let's check with our first term. Now, our first term is going to be now 1 multiplied by a negative 2, and we are going to add or subtract a value so that we can get as an answer a 9. So 1 multiplied by 2 is a negative 2. And how would we move to a positive 9? So 1 multiplied by negative 2, we know is a negative 2. But from negative 2, how do we get to our first term, which is that 9? Yes, we are going to add 11. Let's check if it's true for any of the terms. Let's use the fourth term. Now, 4 multiplied by a negative 2 will, of course, we know 4 multiplied by a negative 2 will give us a negative 8. But we are not looking for a negative 8. If we look there, our fourth term is a 3. So we are looking for a 3. So from negative 8, how are we going to move to a 3? Yes, we are going to add an 11. So we saw there that we add 11 so that we can get to that particular term. So what does this mean for our rule? It means our rule is that term number, or the constant difference rather, multiplied by that term number, and we are going to add an 11. So that is going to be our rule there, a negative 2n plus 11. So what is the answer going to be for our 20th term? That is going to be our negative 2 multiplied by 20, which we are calculating our 20th term. And then we are going to add an 11. Now, do you know what the answer is going to be? Well, if you have a negative 29, then you are absolutely correct. And that is, of course, our 20th term. Let's move on to the next question. Here it says, considering the following numeric pattern, 1, 2, 4, and 8, we are going to represent this numeric pattern in a table. So there is our table. The first 4 terms, of course, we can represent because we know what they are. But for us to find the rest of the terms, we need to know how we are moving from the first term to the second term. Now, we have 1 as the first term, 2 as the second term, 4 as the third term, and 8 as the fourth term. Let's see how we are moving within the terms. So we can see that from term 1 to term 2, yes, we are multiplying by 2. From term 2 to term 4, we are multiplying by 2. This means this is the constant ratio, because even from term 3 to term 4, we are multiplying by 2. Now, let's multiply by 2 so that we can get to the fifth term. So from 8, if we multiply by 2, we get an answer of 16. From 16, if we multiply by 2, we get an answer of 32. And from 32, if we multiply by 2, we get an answer of 64. So that would be now the first 7 terms here. So now we've represented our numeric pattern in a table. Now, that same numeric pattern that we have represented in a table, we need to find the algebraic rule. Can you see the first terms that we have there? So we have a 1, a 2, and a 4. Remember from the previous one, from that 4, we had an 8 as the fourth term, and from that 8, we had a 16 as the following term. So how are we going to find now that algebraic rule? We need to find the rule or the relationship between the term number and the term itself. So remember, we had a constant ratio of 2. Now, that constant ratio of 2 needs to help us in finding this rule. Now, as an exponent, we can place there the term number. But when you look at this pattern here, we can see that if I say 2 exponent 1, it does not give me the first term. If I say 2 exponent 2, it does not give me the second term. Instead, it gives me the next term, as we can see. So what can we do to that term number so that our pattern is correct? Now, what do you remember from those exponent laws? We know that for us to get an answer of 1, our exponent from any number needs to be a 0. So how would we move from 1 to get a 0? We can simply just subtract by 1. We know that 1 minus 1 will give us 2 to the exponent of 0, and that of course is a 1. Let's see if it works for the next term as well. If we in the term number subtract 1, that is going to give us 2 exponent 1, and that of course gives us that 2. Is it the same for this next term here? So we would have the term number, which is 3, and we would subtract 1 from that term number. That will give us 2 exponent 2, and that of course does give us our third term. So what would our rule be in this case? Well, our rule would be the ratio, the constant ratio of a 2, and as an exponent we have the term number, and from the term number we minus 1. So that would be a 2, and we have n minus 1, and that is our rule. Now, can that help us in finding the 8th term, the 10th term, and the 12th term? Definitely it can. So for the 8th term, we are going to say 2, and we are going to have an 8 minus 1, which is of course a 2 exponent 7, and that would give us an answer of 128. The 10th term would be 2 exponent 10 minus 1, that is 2 exponent 9, and that would give us an answer of 512. Do you already have an answer for the 12th term? Yes, it will be 2 exponent 12 minus 1. That is 2 exponent 11. And what answer are you getting on your calculator? If you are getting 2048, then yes, you are correct. And we have now filled out this table, and we have found the algebraic rule. Let's quickly go to an ad break, and then we'll see you just now.